What's up, computational thinking? In this video, we're going to talk about data. Okay, data. This is my YouTube homepage. I've noticed that if I just keep clicking on home, YouTube tries to figure out what the heck it is I actually want to watch, but it seems to have no idea. We'll just settle on the next one. Now, this is pretty good, I guess. Let's see. Okay, look at that. Google coding interview with a high school student. That's cool. I do want to watch that. All right, so on this screen, right? Well, first of all, let's talk about data, because data is everywhere. What does it mean? What does that word data mean? Well, I guess it's kind of hard to use the word data without saying data. I'm going to try. All over this screen, there is information. And that information is made up of different types of data. For example, the tribute to Chadwick Boseman here was created 1 week ago, and it has 14 million views. Well, there's a lot of data there, right? The title of the video is Chadwick Boseman Tribute. The number of weeks ago is 1, and the number of views is 14 million. All those are data points. There's some kind of information about the video. Data doesn't have to be informative. In fact, data can be total nonsense. Let's look at an example. Okay, here's an example of data that doesn't make any sense. Okay? That's just some numbers on the screen. Who knows what it means? Okay. Now, how do I transform this data into actual information? Well, I have to change it a little bit. Okay, 1534.23, that's still relatively meaningless. I'll come over here and I'm going to put a colon. Now it kind of looks like a time. So it's some kind of time. We don't actually know what this time means or what this value is until I add some kind of relevant data to my data to make it information. And this is Katie Ledecky's 1,500 meter swim world record. 15 minutes, 34 seconds. Excuse me, yeah, 15 minutes, 34 seconds, 23 milliseconds. Now it's information. It doesn't change the fact that we had data, right? We have a set of numbers, and now we just happen to have a set of numbers and letters up here. It's all data.
The reason we care about data as it pertains to Python and programming and computer science and all this kind of stuff is that really if it weren't for data, we wouldn't have a reason to write code in the first place. Like, most of the code we write has to do with manipulating data or producing data, refining data. It all comes back to data. If we didn't have any data to work with, programming just wouldn't matter. So it's pretty important that we understand the different types of data that we can work with. In Python, there are several different data types. There's tons. We're going to learn about all the important ones this year for a beginner programmer. However, we're just going to start with 3 for right now to keep things simple. And you need these 3 for your homework assignment that's due this Sunday. So the first data type we're going to learn about is the integer, or whole numbers. Okay? And an integer is just a whole number, like in math. So we would say an integer, that can be our variable, and 42. Okay. That's it. It's just a whole number, all right? We use whole numbers when we don't care about the precision. What would be a precise number? Well, that's called a float. Precise numbers. Okay. Sometimes you can think about these as decimal point numbers or floating point numbers. That's where the name float came from. A float would be 42.37. Now, here's an easy way to put this in context.
We care about precision versus non-precision. Well, if you're talking to someone and you're telling them how old you are, or you're building a computer program that can tell you, or show your date, or happy birthday, you're 32, or something like that, you don't really care about the fact that you're 32.1 when you're when it's, 10 or 15 days after your birthday or whatever. It wouldn't even be that high. But anyway, you don't care about precision, right? You don't care about precision when you are talking about, how many miles it is to get to the store down the street. You're going to be like, it's about 2 miles down the street. But you do care about precision when you're working with stuff where precision matters. For example, you wouldn't want to take a job where they say, we're going to pay you between $8 and $10 an hour. Right? That's not precise at all. You want to work at a place where they tell you precisely you're going to make $9.25 an hour. There's no question there what you're going to be making. That's a precise value. Another example of a precise value that, or a place where we would use it, is like calculating a trajectory of a rocket. You don't want a lack of precision launching you into the sun. That would be one example of things going bad because of lack of precision. Okay, so a float is a precise number, and the last data type we've talked about, or we're going to talk about, is a string, and this is a set of characters between quotes. Now, sometimes people get tempted to think about strings as words, like name, Quincy, or phrases, like greeting is hello. Oops, hello plus name. That's not what we want to think about strings as, because this is also a string. Add or house number. Oops. Wow. Okay, can't type today. There you go. House number 123. Now that's a number, but it's a string. Okay, so both single quotes and double quotes can work with strings. So you could say, my pet is Fido, and we're just using single quotes there. Now, you have to be cautious with single quotes, because if you say, for example, you have a sentence with a contraction in it, and it says, I'm going to the store. Well, this string with double quotes works just fine. But what would happen if we accidentally put, or not accidentally, we just put single quotes here instead? Oops. Okay, so notice how when I do that, it creates an issue where I've got this red squiggly, right? And that's because Python thinks that you are ending that string with that next single quote in the contraction I'm. So anytime you're going to have an apostrophe in the string itself, you can't use single quotes. So it's probably safer to just use double quotes all the time. But in some cases, if you just want to be lazy, you can use single quotes. I do it all the time. These are the three data types that we're learning about right now: integers, floats, and strings. Integers are whole numbers, like 3. Floats are precise numbers with a decimal point. We use them to measure precise things where precision matters, like money or rocket trajectories. And strings are just characters between single or double quotes. They can be letters, numbers, or really anything. These are the three data types you're going to look for when you do your project that's due on Sunday, the Modeling App Data Project. I look forward to seeing what you guys come up with, and stick around. We'll go through a quick review of data types and variables. Let's do some quick review on variables and data types. So first of all, remember that when we talk about variables, we want to think about them in a certain way. So on the right, we have the data that's going to be assigned. And then we have the equal sign, which we now know we're going to call the assignment operator, right? Because this does not mean that apples equals 3. Remember that we say, in this example, the integer 3 is assigned to the variable apples, meaning that apples is now just a label for the number 3, the integer 3. Remember too, we're reading them from right to left, so 3 is assigned to the variable apple. Let's talk about why variables matter. Well, they make code easier to read and write. They allow us to reuse data without having to retype the actual data every time, and we can update them throughout the code as needed. There are 3 types of data that you really need to know right now: strings, integers, and floats. Here's some examples of each. Strings are characters between quotation marks. Integers are whole numbers. They have no precision, or low precision, we would say. And floats are decimal point numbers or numbers with high precision.